No comments.
So, welcome everyone. My name is Jakub. I work in the CERN Cloud Team, and today I would like to describe my journey from becoming a contributor to an operator. So, I'll make it as a story. I'll describe how I contribute upstream. There's no way that my experience contributing to upstream will be similar to any of the cores upstream. This is more like an individual contributor or like a newbie contributor to OpenStack. Then I will switch sides and talk about how I became an operator and what's different. And I'll also describe some of the struggles of operators. And I will describe this on one feature that was developed, and as an operator I was tasked to deploy it, and then I had to fix up the mess that I caused as a contributor. So first I'll describe the contributing part. So I was introduced to the beautiful world of OpenStack as a summer student at CERN. This is a program that CERN organizes since 1962. Each year around 300 interns come to Geneva for the summer, and they are working in a variety of fields such as IT that I was doing. So I worked in the CERN Cloud Team for 3 months, and my task was to contribute upstream to OpenStack Ironic. So I don't know if you're all familiar with OpenStack Ironic, but it is important for this story to know a little bit of the basis. So I'll try to describe it. OpenStack Ironic is the component of OpenStack that communicates with the hardware itself. There are probably around 20 repositories which Ironic as the community manages, but I need you to know only of 2 for this presentation. So there's the Ironic repository itself, which consists of the API and the conductor. And the conductor then communicates with the Ironic Python agent, which is the RAM disk, which is built as a RAM disk, which boots on the hardware itself and then can send data to the conductor. So, what I developed during my internship is a mean of keeping data from being deleted when you reinstall a node. So this could be interesting for you if you have, for example, a Ceph cluster or like a storage node. You will have a petabyte of disks there, and you need to reinstall it from, I don't know, rel 8 to rel 10. The reinstallation itself can take a couple of minutes, but if you need to evacuate the node, it can take several hours. So maybe if you are operating these nodes, you will take the sacrifice of a couple of minutes of downtime without evacuating the node and just reinstall it. The issue is now, if conductor tells IPA that you want to reinstall the node, which means that you need to go through cleaning, then it will actually clean the node and there will be nothing left on the disk, so you need to evacuate it. But with this feature, we wanted to prevent it, so we developed a format where you can specify lists of disks that should not be touched. This is a very simplified because I couldn't fit it on the slide, but if you're more interested about it, if you search for a property called skip block devices in the Ironic docs, you can figure out how to use the feature or just ask me. And you can specify hints as you will do for root devices in Ironic, where you can specify either WWNs for like unique identifiers of disks, or you can also specify like all disks which are bigger than 900 gigabytes, and then it also finds them. The feature is very simple for physical disks, but then as a stretch goal during the internship, we tried to implement it for RAID arrays, and that was a bit more involved. We had to start by introducing a unique identifier of the RAID arrays, which would be consistent between reboots. and we just used volume names, which are a built-in feature into MDADM, but were not supported by Ironic. Because now, without this feature, without being able to specify volume names, the only mandatory fields of volumes as RAID arrays were the RAID level, like 1, 2, 1, 0, or stuff like that, or and the size. And if you have two RAID arrays, which will be both RAID 0 and they will have 2 terabytes, then like which one is which, you can't tell. So we have to have a unique way, so we specify the volume names. And I'm saying it because it will be important in this talk. So how we tested this feature, I deployed DevStack, which is a test environment for OpenStack. And I have to say, as a beginner who needed to build a DevStack which would allow you to build IPA from source, it took me a while because the documentation upstream did not specify it. So I had to ask loads of questions, and I only managed to do it after around 3 weeks. And I also had to ask for a bigger RAM, because apparently 8 gigabytes of memory is not enough for doing stuff like that, so I needed 16. But DevStack, I don't know if like you can specify that you also want like fake nodes, but the only issue is that these fake nodes are not physical hardware; they are VMs on a DevStack VM. So they can very well test that your feature has the correct logical flow, but they can't test everything. So that's where the unit tests come in. Unit tests are great, but when I implemented the feature and I told my supervisor at the time, like, yes, so what do I do next? He told me, yeah. So now you'll probably spend like 3 times as much time on the unit test other than the feature, because everything in Ironic has to be mocked, and like the tests look kind of scary, but it has been done. But still, simulating the rate is a bit tricky, because you need to like mock everything. Like you need to fake the outputs from MDADM, you need to fake all the RAID devices and everything that's returned between the function calls. So that could be some sort of errors. And you're asking like, hey, you were at CERN, like, well, why did you just not use the real hardware? But I was there only for 3 months. I was busy implementing the features, and my supervisor at the time, or my co-supervisor at the time, Marina, was busy with making the data center not fall apart. So, like, not that CERN data center is bad and everything falls apart, but you know, like the team is small, so we just have other priorities, as you will see in the later part of the presentation. But due to time constraints and also practical reasons, such as that CERN was running Wallaby and I was contributing to Z, and like backporting the features was just difficult, we did not manage to test the RAID on actual hardware, which was not ideal. But to summarize, I started contributing during my internship at CERN. I developed a feature in OpenStack Ironic, and the biggest pitfall was the testing on real hardware, because I did not really have access to it. That's why I always had to ask people to test it for me. And I would like to take now time to thank the upstream community, because they were very welcoming. They answered all my questions that I needed, and they helped me set up a DevStack, for example. And I contributed upstream to other projects before, but they made me, like in OpenStack Ironic, they made me feel welcome. So, for example, I did not run away, and I did my bachelor's thesis with them. But after I was done with my studies, I rejoined CERN, but this time as an operator. And as an operator, as I said, Marina was busy not making the data center fall apart. it kind of happened to me as well. So we have we have priorities, and the top priority is so that the data center still works. But I was hired as a bare metal engineer or something like that. I don't know. I don't remember the blog post. The blog post or the job post at CERN are always very vague. But I was hired to do Ironic, and I don't know if any of you have been to our Linux version OVN migration presentation yesterday. But you can tell that I'm not doing just Ironic. I do just everything that's needed. But anytime we plan for the next year at CERN, we always have to plan only for like 30% of the time, because the other 70% is like firefighting and answering tickets to users. So being an operator is great, but it's a bit unpredictable. And my first task that my supervisor Jose gave me was to actually deploy my safeguards in production. But I mean, this task was a bit delayed because you have to go through the onboarding and stuff. Because obviously everybody has to do the radiation protection training. And then I was introduced to our rota, so I had to answer tickets, and if anything was broken, I had to do firefighting. But the important bit was that after a couple months, I was able to upgrade Ironic from Yoga to Z. You can tell that there has been 2 years because we upgraded from Wolby to Yoga. So then I upgraded Ironic from Yoga to Z, and Z is the release that I contributed my safeguards to. So we were able to test it on real hardware. And real hardware is very much different from the fake nodes in DevStack, because in DevStack, I was running it on my laptop, so there was just some VMs on a VM, so they had no disks and stuff. In the CERN QA, we have loads of nodes. We have loads of different specifications of nodes. So, for example, this node I think has 16 disks, so we can test all the possible scenarios of RAIDs and stuff that we need. And and with the physical hardware itself, we found some bugs. So, but first, before I explain what the bugs were, I would like to say that there was a user called Pipes who reported the first bug that we hit, and this is probably the best reported bug I've ever fixed as a contributor, because they identified the exact line of code that needed to be changed. So once we figured out that this is the bug that we hit, it took me 10 minutes to change the 1 line of code and then the 20 lines of code of the tests. So thank you. But to operators, if you can, file bugs like this. But if you want to add the cherry on the top, you can also try to draft the change upstream and try to push it. But we took a while to fix all the other bugs which were not apparent. I started fixing it in the first couple of months when I was employed at CERN. But the fix that we created with my intern Morten was actually merged maybe 2 weeks ago. So we even missed Flamingo release, so it's gonna be released in Gazpacho. It is the biggest change that I've made to upstream. We added 1,500 lines of code, and this is not a good thing, as I will explain later. But there were loads of problems with the initial safeguards for RAID that I mentioned. For example, why it took so long? I was stuck on checking the wrong partition of the RAID. And then Morten came, my student, and I gave him the task, hey, could you check this? And he came 2 hours later, hey, Kuba, the partition is not supposed to be there. It's supposed to be on the other one. But how I was enclosed in the site looked the super block was deleted. I just couldn't take the step back and figure it out. So shout out to Morten for figuring it out. Then Julia, one of the cores upstream, made a quote that I'm now the new software rate expert. I don't know if it's like all the questions that I ask about software rate or just submitting loads of patches to IPA, but I don't know, maybe I created an impression that I have a clue what I was doing, but I'll take it as a compliment, I guess. But yeah, but back to the story. So as a there are some things that I had to do as an operator that I did not have to do as a contributor, which I'll describe now. So the problem is that if you submit a patch upstream and it gets merged, that's not really where the job for the operators finish. So yes, we have a change upstream, but we need to like get it to actually run in the production. And as I said, CERN was upgraded to Z. Since then, we were very lucky that we were allowed by our management to focus on upgrades. So we are running some of our regions in epoxy now. But as I said, we merged our change to gazpacho, so we still need to backport it. And the size of the change makes it really difficult because there are quite a few merge conflicts, and upstream doesn't want to really, and like it's for obvious reasons. It's a very big change. We deprecate some stuff and we change some behavior. So merging it to a stable release is just very unlikely. Maybe we'll be able to fix some things, but probably not all of them. And but once we backport it, we need to make sure that it is production ready. So we use Rally to deploy and like provision an instance of Ironic in all our regions every hour. And that is actually what we are doing now with this change. So we are making sure that we do not break anything, and we always taste a rate node and an unrated node. So in summary, from my experience being an operator, is a balance of priorities, but the downstream priorities are like have way more priority than the upstream. So even though we have access to all this lovely hardware for testing, we cannot just contribute features upstream because there are tickets and users. So even though I would kill for, or not actually kill, to have a node like that, or even one of the nodes that we have in our QA environment when I was doing my bachelor's thesis, and I was just running all my testing on a laptop with, I don't know, 60 gigabytes of RAM, it will be lovely. But now we can use the hardware that we have to gain more trust with upstream, and we can get features merged that probably would not have merged if I was just an individual contributor. And I had to, like, for example, for the 1500 lines of code that I changed, I had to convince upstream, like, hey, we've actually tested it on real hardware on several different platforms, and it works, so it's okay. So one of the cores was like, yeah, okay, I'm convinced, it's good. But also, the deployment takes a bit longer than just contributing upstream and submitting the patch. So with this presentation, I wanted to highlight that it's nice, and we should collaborate with between upstream and us, the operators. If you can, and if your management allows to, please contribute, or either by submitting bug fixes or just submitting the code itself. And at CERN, we have this as a priority, so we try to upgrade as much, as close as possible to what upstream has provided, and we are gonna be at the PTG so we can provide some feedback. So these are the sources of the icons that I used, and I would like to thank you for your attention, and I would like to thank everybody that was involved in my journey and who has helped me to get where I am. So if you have any questions, please.
mentioned rally testing about kind of new features, I guess.
Yeah.
Did you use the verification part or the rally itself?
So we run Rally with the. So basically, we use Rally as a benchmarking tool for something that's completely different. That's basically doing the kind of validation that they. So we run the machine every hour, and we get the report, and we upload the results of the report to our monitoring system, so we get a kind of a trace or trend of how has been running over time, all the tests. So we get also if there's a degradation on the service taking longer than before. So we get trends of completion of the task and also the time that it takes for doing each of the tasks we can. And we do it over all the resources that we have, but in particular for this in Ironic, we do it for